Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for the event, and I welcome you. As always, we have a great webinar on tap today, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it on demand. Following today's webinar, we will be sending out an email to everybody that will include a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during our presentation today, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll take hopefully about 10 or 15 minutes near the end of the presentation and go through those questions. Okay, with that, we'll go ahead and kick off today's webinar, which is mapping data flows across apps, microservices, and APIs. Our speaker today is Eitan Lightstone, who is VP of Product Design at Shift Left. Welcome, Eitan. Thanks for joining me today.
Thank you very much, Charlene.
Excellent. Well, I'm going to put myself on mute and just let you do your thing.
All right, sounds good. Well, welcome everybody. Today I'm going to cover a few topics. I'm going to start by just describing, the status quo of why mapping sensitive data flows in modern software is getting much more difficult now. I'll also describe a few modern leakage scenarios that we see today and get into sort of a novel approach for mapping sensitive flows using a semantic graphing technique. And after that, I'll show a quick demo of the shift left solution and how we have deployed this kind of technique. And as Charlene mentioned, I'll get into some questions and answers at the end. So before I begin, I should point out that we won a few awards. This is something that the head of marketing has forced into my slide deck. So I'll mention that we won the Gartner Cool Vendor Award, which we're very proud of, as well as we've been voted into the RSA Innovation Sandbox this year. So if you are attending RSA, I encourage you to come talk to us. And of course, what we're most proud of is DevOps Dozen award winner for Best New DevOps Solutions Company, which is super cool because it was voted in by the community at large. So this is pretty neat for us.
Congratulations on that, by the way.
Thank you very much. So I probably don't need to tell you that, with modern software companies today, sensitive data is probably one of the most valuable assets that we have. And mapping the flow of sensitive information in modern software is very difficult now. This is because of modern development practices like faster release cycles, which means there's a lot less time to understand code. We're seeing more modular architectures like microservices, which means the information or the handling of information is more siloed in a technical sense, but also in a human sense, because people who are members of different teams own different sections of software now. So it can be very difficult to get a holistic understanding of how sensitive data is treated by software. And of course, there's increasing use of open source software and third-party libraries or APIs, which increases complexity and can lead to external data leakages. And last but not least, there are now more stringent regulations that define new kinds of data as being sensitive, as well as forcing companies to really be diligent about understanding their usage of that sensitive data and where it resides. So if we consider a modern architecture or a typical architecture, we'll have a variety of applications or microservices. They may be deployed in a data center as well as a cloud service. And they're typically exchanging information with Oracle databases or S3 storage buckets, like personal information, healthcare data, credit card information, and information back to the customer, perhaps over a web UI. And in this kind of ecosystem, we frequently see unintended data leakages out to logging systems like Splunk. One example that comes to mind is, I believe last year, Twitter, they had left some debug code into production software, and that ended up logging plain text usernames and passwords, millions of records, to a local file. So that could have been devastating for the company. Another example I remember is last year, Uber had published a private key into their source code that ended up on a public repo. So an attacker was able to harvest that key and then use that to steal millions of driver records from Uber. And I don't have a Salesforce example, but many software applications will send customer records to Salesforce, and this could be an easy place for personal information like social security numbers to end up where it shouldn't go. And so, how do we manage this situation? It obviously requires an automated approach because of how difficult it would be to do this manually. So we're developing something novel called the code property graph, or I should say we have developed the code property graph. And you can think of this as a graph of flows of your application logic and how it handles each piece of data in your application code. And so we have to map a flow across your logic, as well as how it flows into any open source dependencies or any web frameworks that deal with I/O. And of course, low-level VM-like libraries or low-level language libraries can also be handling that data, perhaps logging to or saving it to a file or doing something else at the OS level. And so if you assemble thousands of these flows, we have a graph that we can query for the purpose of sensitive data investigations. And so let me first describe what one of these flows typically looks like. So when we analyze source code, we look at each data variable that's initialized or comes into existence, or perhaps a class in an object-oriented language, and we look at how that object transits through the code in one flow. And so a typical flow starts with a trigger on the left-hand side, which is what initializes the logic. And then we look at transform functions, which touch that sensitive data or that data along the pathway of code until a final saving function, which ultimately puts that data out to a data sink. And so the first transform function in this particular case is what's querying the data. It's what's initializing the person object after grabbing it from a database. But a transform function is basically any function or method that manipulates or touches the sensitive data object in some way. So if the first one in this case is the querier and initializer, the second one in this particular case is an encryptor. And so this brings up an important thing to mention, which is transform functions can do anything to data. So it might be just renaming the variable or concatenating it into another string or putting it in a data structure, but they also can encrypt the data or escape it or obfuscate it in some way. And so this is an important way that we can determine whether a flow is dangerous or not in its handling of sensitive data. And of course, if the data is going to an undesirable data sink or exit, then that is also what would make a flow interesting from a sensitive data standpoint. Last thing I'll mention, actually two more things I'll mention. One is the trigger can sometimes also be the place that data is queried into. So in this example, that's not the case, but if we have like a typical web transaction where form inputs are handled by application logic, then those parameters coming from the web will come into existence into the trigger function directly. So it's a subtlety. And so the next thing I'll describe is the semantic part, which I mentioned earlier. If we look at each data variable, or excuse me, object or class or variable name, and we look at how the name is spelled out, if we use some basic natural language processing, we can actually attempt to automatically categorize that data and identify whether it's sensitive or not. So in the case of person, that may be identified by the natural language processor and automatically cataloged as PII or personal information. And this is sort of a machine learning mechanism that you could tune over time. And there are a variety of ways to do that kind of natural language processing. And so if you consider the flows and the understanding of that information semantically, and you take thousands of those flows and you assemble them into a queryable data source, like a graph database, then we effectively have, what Shiflef calls the security DNA of the app, a queryable database record of, a queryable graph database of the application itself. And we can query it to understand all the entry points of sensitive data into the software and all the exit points as well. And we can use that to ultimately flag the sensitive data leaks that we've identified. And another sort of novel thing that can be done with this approach is we can detect vulnerabilities. And the reason this is possible is because if you consider a typical vulnerability, ultimately it's usually an input that is vulnerable to an attacker. And so the attacker puts something into that input. That input then is absorbed by application logic or a data flow. And ultimately at the end of that flow will cause some sort of damage. And so this approach can detect vulnerabilities in your custom code and dependencies, and all of this is, without relying on any, third-party CVE database. This is just inherent understanding from a control flow standpoint, whether it's vulnerable or not, which is pretty cool. So, yeah, I think before the demo, I want to point out one thing. So, this is, if you imagine this as a queryable graph database for one application, if you can build this data structure efficiently from source code analysis, you can assemble this for each version of an application. But in addition to that, you can assemble this for every application and decide how to, and analyze that flow of information between multiple applications as well. So I'm going to show a quick example within Shift Left on how we've done this, how this works. So let me move over to the browser here. I have an application, it's an API service sort of that I'm running locally. I'm just going to hit it a couple of times so that we have runtime data. And I did not describe anything to do with runtime, so I'll explain why in a moment. So if I switch over to Shift Left, so I've just logged into the Shift Left product. And here's where I'll just mention that this security solution is a two-pronged approach. There's a code analysis part of this, which is building that graph database and analyzing it for vulnerabilities and sensitive data usage, just as I've described in the presentation. But in addition to that, the code analyzer automatically configures a runtime agent, and that runtime agent is deployed with the application in runtime and monitors it for activity and attacks. And so those two data sets are basically combined in this experience. So as I walk through this, consider that most of these insights are coming from code analysis as well as what we are detecting in runtime. So there's one application here, which is my test app called Hello Shift Left. I'm just going to click into this. And what we have here is the application summary view, which is really a viewer of sensitive data flows. And so I'll just walk through what we see in this experience. The first thing I'll mention is this top chart, which is the application throughput chart. You can see here that there's just a little bit of spike of activity here as I've only just now hit the app a few times in my browser. And then on the left and right wings of the UI, we have triggers and data destinations. So triggers, just like I mentioned in the slide about a data flow, triggers represent the beginnings of all of the data flows for this application, which trigger these, they trigger the flows. Now, in this particular case, it's a web service. And so the analyzer does the dirty business of figuring out what the routes are, because we know what we have annotations for most frameworks. So in this case, instead of showing those triggers as calls or methods, we show them as URLs. On the right-hand side, we see a variety of data destinations. In this case, this application sends something to the log, sends information back to the web because it's a web-facing service, as well as other destinations. So one thing I'll dig into right away is a concern I have right here. Actually, since I touched it, let me just describe the middle widget. As I'd mentioned earlier, because this analysis technique can also uncover vulnerabilities in source code, this panel describes at a high level all of the detected vulnerabilities we have. So in this case, we've got 80 injection leaks or SQL injection leaks. There might be command injection as well. So 80 injection vulnerabilities, I should say, that have been detected in code. So that's 80 places in the source code. And then one of those places we either detected and blocked an event at runtime for one of those 80. So I guess back to the data destinations, let's quickly explore one of these data flows. In particular, you're seeing a lot of red because this test app we've littered with security issues and sensitive data leak problems. So there's a lot of stuff going on here. But let's say one major concern I have is sensitive data that has been auto-cataloged as payment data that is being sent out to the log. So that's a concern, and it's highlighted red. I'll also mention that these bars filled in represent relative runtime activity for these data flows. So in other words, payment data is being saved out quite frequently compared to some of these other ones, where like medical, much less frequently. And you'll have some that aren't sending any information, they're just black. So there's no runtime activity detected for those flows. So this is one of the unique advantages of having the hybridized analysis and runtime solution together, where you can kind of see at a glance that, okay, so I have a variety of leaks that are happening from these flows. Some of them are receiving runtime activity, so I would prioritize those over others which have less or no activity at all. And the reason they have no activity is either they're very rare pathways in your code that just are rarely touched at runtime by a customer, or it's conditional logic, or maybe deep staging only logic. So you can have a condition where parts of the app just don't activate in production, and so they will never happen. And so this is a great way to kind of mitigate false positives and prioritize what is the most concerning. So payment data, I'll click into this. And this effectively filters the entire experience. So I'll just point out at the top here, we have two filters that were applied now to the experience. One is we're now seeing all triggers and destinations for flows sending something to the log, as well as flows involving variables flagged as payment data or cataloged as payment data. So now we see fewer triggers. So these are there's just two triggers here that are involved in these in this filter, and there's a data source down here, and then on the right hand side under log as the destination, instead of seeing these sensitive data categories, since now we're only inside one of them, payment data, we're now showing the individual variable names. This particular case, we have a Java application, so these are Java variables that were associated with payment data going to the log. So I'll just dig into one of these. Let's look at account number or account. Let's look at account, which is a model. And if I click into this, we actually see the raw data flow itself, lines of code, starting with the trigger. So this is the triggering. This is a relatively short flow though, but we have the trigger, which is the customer controller get customer action. So this is the case where the trigger is also the one receiving a web parameter, I believe, and initializing account. No, it's probably doing more than that. Sorry, I don't know the code super well, but it's receiving it as account, which got flagged. And then by the end of this flow, we see it's sort of fed into the logger via param1. So it's one of the parameters in an info call from the logging system. So this is pretty interesting because we started with a high-level view, almost an operational view of the application, its overall throughput activity. We're seeing that throughput activity reflected in those data flows, but then we can quickly get to a level of depth where I would look at these lines of code, determine perhaps that this is a real issue, and involve a developer or file a ticket for a developer to fix and just paste this in. So that's pretty cool. If I go back, I can show you there are also much longer data flows. That one was short, so if I go to initial balance here. So now we've got initial balance flowing in from a trigger, which was also flagged as payment data, and then it goes through a variety of calls between the trigger and the destination here, which in this case is logger once again. So one other screen I'll just show you really quickly is, this is a very data flow centric viewer into the health of this application. If I click on this vulnerabilities dashboard, we can also get a sort of explorative list of vulnerabilities, including the sensitive data leaks here, that have been detected for each version of the application. So this is a kind of important time to emphasize the fact that it's not enough to analyze your app once. And in fact, I know from experience that a lot of the code analysis tools that we're familiar with, they can take a very long time to analyze your application, and because of that, they're not well integrated with modern DevOps or modern development cycles. Because of how slow they are, they would interfere with the regular deployment cycles. And so in the case of this particular technique, this semantic graphing technique, we have a very efficient analyzer that can analyze large code bases in minutes. And so they will integrate nicely into an agile practice. And what we see here is this top histogram is actually showing the history of detected security problems from right to left from current back to the past. So right now we have the rightmost or the most recent analyzed version of the app selected by default, showing the list below of vulnerabilities. And I can click one of the previous releases, and I get some stats on the right about that previous release and the list below. And I can dig into these one by one and determine what I'm going to do about this. And I can fix it or assign it to someone. And so this is another interesting way to kind of look at the same data set from that analysis and runtime monitoring. The runtime part, by the way, is also in here. So we'll see if I can sort by security events. And now we can show this list of vulnerabilities, which includes data leaks, by the number of security events. So back to the application, I spent quite a bit of time digging into the analysis of this one application. But as I'd mentioned earlier in the presentation, most modern architectures have a multitude of microservices that kind of work together as a living organism. And really, to understand whether sensitive data is flowing safely through that organism, you kind of have to look at that holistically. And so what we're really excited about is something we're working on now, which will be coming out soon, called the topology view, which assembles, and I'm just going to switch to this, which is just a concept, which basically rearranges your application list, if you had a multitude of applications, into this automatic topology view, which uses the agents to determine which services or apps are communicating with each other. And so now we have these applications talking to each other, like storefront UI with account service, that also communicates with these shared data syncs. And so we can use this as, first of all, a way to understand just architecturally how things fit together. As you know, depending on the size of your company, you may have thousands of apps or services. So you can freely group those into folder structures, which can still remain on the topology view. And you can save multiple variants of this view. That way, if you do have a really complicated architecture, you can have different lenses kind of at the ready, where you've rearranged it and grouped different things. But the most important part is we can leverage that the graph database of all of these applications and query it on whole to get that holistic understanding. So I'm going to click on the left here, which opens this overlay panel, which allows us to overlay different kinds of information onto the topology view, like a cellophane overlay. So for sensitive data, I can hover over these categories. And now if you see the yellow highlight on the pathway between storefront UI and AWS East group, we can see medical data flows between these two. And I can hover down these other ones like PII, and now I'm seeing it flow through almost all of the topology, or authentication data, which I see flowing from storefront to account service to account DB at the end there. So this is a pretty neat way to query across the whole architecture to get that really glanceable perspective on the flow of the sensitive information through the architecture, which is pretty exciting. Looking forward to this. So that's the end of the demo. Let me switch back to the presentation. And so what I'll do now is just make a quick announcement and then get to Q&A. So I will make this full screen. No, play from current slide. Yeah, so at this point, I'd like to mention that if anyone has not yet talked to us who would like to come talk to us, we are offering a free data leakage assessment. So what this effectively is we would use our analysis on one of your applications, and it will output an emailable PDF that basically lists out all of the detected sensitive data and the flows that that data participates in for a application. So that's pretty cool. There's a link here, and I believe you'll get the link shared via another way through either GoToMeeting or email afterwards. Charlene maybe remembers. But yeah, I'll show this again at the end of the webinar. And so,
sorry, I don't mean to interrupt you, but yeah, folks will be getting in that email link, in that email that comes out after the webinar. The link will be in that.
Okay, excellent. Yeah, so the report looks like this. The left-hand side is just a cover page, but the right-hand side is a summary of sensitive data, and then it. Oh yeah, it keeps going here. So if you look at the page 4 there on the right, it will list out that sensitive data. I can't really zoom into this, so this is just an example. Okay, so I think at this point we're into the Q&A phase. So I'm going to dig in to see what questions we've got. Sorry, I'm reading and then I'll talk. Does this kind of analysis work with HTTPS in addition to HTTP? How about other protocols? Okay, so this is a good question. So yeah, the interesting thing is almost everything I've showed you, most of those insights are coming out of code analysis. So in fact, it's fairly agnostic to the protocol. Now, there is instrumentation involved in the code analysis that determines whether a trigger is a web-based trigger or a destination is a web destination, so network or web destination. But because it's analyzing code, it doesn't really care that it might be SSL encrypted. On the runtime side, the good news there is if you consider other security products that run on the network, you have to figure out whether they need to be behind encryption or not. Because the runtime part uses an agent approach, and this is a very similar agent in terms of how it works to an APM agent, and I'll just speak to Java as the example that I know, where it lives in the virtual machine with the application. So it's very much behind encryption as well. So it does not matter if it does not matter if it's HTTPS. Okay, I'm gonna keep going here. Oh, I did it again. Okay, sorry, I did it again as one of the questions I accidentally deleted, unfortunately. Okay, this is a good one. How do you categorize sensitive data? Is it based on the variable naming convention? Yes, so it is based on the naming of the variable. This is a big departure from how data is identified, by the way, by a lot of other security products that actually try to figure it out in transit. So in other words, it'll look at on the network the contents of a packet, or I guess you need to assemble a bunch of packets. So it would look at the contents of information on in transit and try to figure out based on the value whether, hey, does this look like a credit card number or not? That tends to be extremely error prone, requires a lot of tuning, and there's a network overhead to that. So yes, as I pointed out, the code analysis tries to read the names of the variable in code. And you're absolutely right. It is based on conventions. So if a developer has chosen a name that just is not recognizable, or just like XYZ as a name, then it would not be automatically identified by the natural language processing. However, it is customizable. So there is a policy that drives the results that you see after analysis. So that policy can be used to augment effectively the dictionary of variables, and then you can decide on the category or invent new categories if you like, especially if you're part of like an exotic business domain, just may not have variable names that make sense to the system at all. So you can still augment that policy and have those cataloged. Yeah, so I think I'll keep going here. Yeah, so can this tool identify data leaks between applications? Yeah, so if you think of the analysis within one application even, you can obviously see sensitive data going to a third-party API. Now, if it's an internal API, another microservice within your network, I believe there may be a policy way to define what that is, and then you can flag that as a leak, or that would be automatically flagged as a leak if seen in the future. But with the topology view, that would further automate it, because now what we do is because we know which agents are talking to each other within the same organization, then we can inherently know whether that data is being shared externally or internally. Now, you may also have services within your organization that are allowed to touch certain kinds of data and services that are not. And so making sure that is flagged correctly. So obviously all the information will be visible to you, but you have to determine what is red or green, to you. So at the end of the day, if a service is not meant to touch private customer information, you may have to augment the base policy. But I should say that one of the things we're passionate about is an instantaneous out-of-box experience. So, if you were to install this, there is a default policy. You would get results right away. You would see some sensitive data right away. You just may not see certain things highlighted as red. And so in those cases, obviously you may need to augment the policy to reflect that, hey, this is not good. And then it would be fine from that point on with subsequent analyses. How does the pricing model work? Because I'm head of design, I'm a little distance from pricing, but I really encourage you to come talk to us. That's all I can say. I will tell you that our pricing is, we're trying to be cloud friendly, and it's meant to scale for enterprise and smaller companies. So we're very much a SaaS business, and we know that other people are in the SaaS world too, in case that is a concern. So that's all I'll say about pricing, but yeah, please come talk to us. Sorry, I'm reading questions, that's why I'm going silent. Here's an interesting, are the data destinations dynamically generated by the code analysis engine? Yes, they are. Now, there are levels of visibility that can get better or worse depending on a few things. So if you're just thinking about code analysis, because our analyzer has annotations built into it for most modern frameworks and libraries involved in I/O of various kinds. So that will include anything that is a typical. I will speak to Java just because that's my comfort zone. Other languages obviously have their own popular frameworks, but in the case of Java, we have automatic annotations in the analyzer that recognizes the use of struts or Spring. So that's the web side. And we can use that to determine sensitive data flow out to the web or data leaks out to the web. And of course, there are other popular libraries for interacting with a database, and that's how we recognize those data destinations. In some cases, you may be using your own library or just something extremely obscure, in which case we will not see the destination, but it's very easy to augment the analyzer yourself, or we would work with you to do that. So If you don't see destinations that should be there, then we add that annotation, and then it's there from that point on and detected automatically. But for the most part, yes, it's automatically generated. Still reading. I see. Thank you. You're welcome. Yeah. Let's see here. Here's a question for what languages does shift left support? Yeah, so I've talked a lot about Java, but we also support .NET. So those are the two languages right now, which are the most popular as far as we know. However, we know that a lot of customers are asking for a few other things like Node.js, I believe, is going to be one of the next things we work on. We're also considering Scala, and then as we get further down the roadmap, things like Python and Ruby on Rails and stuff will be considered. So I would say yes to Java and .NET right now, and then soon after Node.js, if I recall correctly. Let's see here. Oh, someone else asking about Python. No, so today it does not support Python. It's a little down our roadmap. So here's a question. What is the impact on my runtime performance speed? So yeah, we get that question a lot from customers where overhead is always a big concern, and there are cases where a runtime solution will have an unacceptable amount of overhead. And this is something that we were worrying about from day one in the development of our runtime agent. The good news here is the performance is basically negligible in our case. That's why we call I think our market speak for it is a lightweight agent is what we call it. Micro agent, one of the two. Anyways, it's extremely efficient. One of the reasons it's efficient, if you compare it to an APM agent, which is an application performance monitoring agent, which is like a magnitude higher overhead than ours. The reason for that is because an APM agent has to kind of deep trace everything, and you'll see these like long traces in tools like New Relic and App Dynamics, and those all have to happen in kind of real time via the runtime agent. In our case, we have this advantage because the code analysis, which is totally not runtime, is really building the bulk of all the insights and pathways and names of transactions. And then on the instrumentation side, we really only have to monitor just a few calls in order to infer traffic through those data flows, which means that means there's much less instrumentation going on, or at least much less processing going on in runtime. So yes, it's pretty quick. I missed the initial part of the webinar. Do we get a recording of this webinar after it's done? Usually we do. Charlene, are we?
Yes, we'll be sending out an email after the event that contains a link that will enable users or attendees to actually access the webinar on demand, so they can listen to it again, or they can just pick up where they left off, or whatever. But yeah, they'll be given the opportunity to listen to it again.
Cool. So last question here. Does the platform have any specific strengths when we consider security analysis of open source software? So that's a big topic. I'd like to think yes, and I'm pretty sure objectively the answer is yes, it does have specific strengths. So one example, very common security approach is relying on CVEs, and if I'm over-explaining, I apologize, but a CVE is basically an online database of known security bugs in open source software. And so this is an easy way for tools to tell you, hey, you're using version 1 point whatever of struts, and it has this vulnerability. So we recommend you upgrade it. The problem with that is if you are a very big company and have been writing software for a decade, and you've had thousands of developers touch that software, it's easy to know that somewhere in your code base, that you have this library, this version. It's very difficult to know, A, how much damage has been done already, or even are you even using the library, the vulnerable library, in a certain way that exposes you to this threat? Because it's very possible you have the vulnerable library, but not necessarily true that you're leveraging it in the code or leveraging it in a way that exposes you to the problem. So in the case of the analysis solution I've described to you today, it's a completely different approach where we don't need to rely on those CVEs. Instead, it just inherently understands the flow of information, and it just tracks that information as it goes through any open source dependencies in your code. So not only can we say that there's a vulnerability, we can say that, yes, you're actually using it in a way that makes you vulnerable. We can say you're using it in these 13 different places in your code across a variety of apps. And we can tell you whether or not, there's runtime activity invoking those flows or even an attack on those flows. So it's a pretty, I would say, powerful advantage when it comes to the concern of open source security. So yeah, I think that's my best answer for that. So at this point, I don't see any more questions. So maybe I'll pass the mic over to Charlene, who will conclude things.
I'll say nice things and close us on out. All right, great. So thank you to everybody who did submit questions. There were some really good ones there, so appreciate the time and effort you put into it. And as I said earlier in the webcast a couple times actually, that today's event has been recorded. So if you missed any or all of the event, you will be able to access it on demand. As I said before, we are going to be sending out an email after today's event that will include a link to access the webinar on demand. And the webinar is also actually going to be living on the devops.com website. So you can always look for it there. Just go to the webinar section, click on demand, and it should be right there waiting for you. And then while you're there, go ahead and take a look at some of the other webinars that we have both upcoming and on demand. Hopefully there'll be 1 or 2 or 3 or 4 that pique your interest. Eitan, thank you for giving such a great presentation and demo. We really appreciate your time.
Thank you very much. It was a pleasure.
Excellent, excellent. All right, great. Well, I also want to thank the audience for attending today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.